And here it is, 38 seconds later. We're back to our original look here. We're going to add noise, texture noise. So not render noise like the artifacts we would get, what we were spent a lot of time talking about in terms of optimizing your render, where you get graininess. We're not talking about that noise. We're talking about intentional texture noise. In particular, we want to break up. If you look over here, there's like this hard edge and all these hard edges. We're going to add noise to everything. And it's just a great way of getting more rendered detail into your sim without actually increasing the simulation time itself. So we're not literally going to add voxels. What we're going to do is when the rays come out from the camera to sample the volume, they're going to encounter rest coordinates, which are volumes or fields that store the position of the volume, and we're going to use those coordinates to look up into a 3D noise. Now, I know that sounds complicated, but it's actually not as bad as it seems. So what I ended up doing is we have rest coordinates because I asked you to turn this on in Dynamics 2. If you're not starting from Dynamics 2 and you're just doing the cool cloud that we made, that's fine. If it doesn't find the rest coordinates, it'll just use the position in space. And that will have to do for now in terms of, for our purposes here to learn about it. But the great thing about rest coordinates is that they're actually advected through the volume. So I ended up showing that here. These colors represent the values of the rest x in this case. So here's this volume visualization node. And basically what I asked it to do was the density will be the shape as it usually would be. And then I'm actually saying colorize the density based on the rest x field in particular. So you see x here is left to right, largely left to right. And so what this is saying, as we go from -8 to 8 in the actual world x, and you can see it's 16 units wide. So the idea was, 8 minus -8 is 16, so it's 16 units across. The middle is 0, because you can see our little guy there. This makes it more easier. Is basically centered right on the origin is the point. So right on the origin, right at 0, you see it changes over from red to blue suddenly. And that's what this dividing line is down here. And then I have it taper off towards yellow to the left, tapers off towards green to the right, and that's what you're seeing. If it was just world space, though, we wouldn't see this. This is a top-down look. Watch how everything starts to spread out, but every 10 frames it gets snapped back. In particular, so here we go at 32, snapped. Goes, 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 goes. See how the red is bleeding over to the right side and the blue is bleeding over to the left side? That's because on this frame, all of their positions in space, every voxel records where it is in space. There's an x, y, and z coordinate. That's why there's a rest x, a rest dot y, a rest dot z. And I'll explain why there's 2 in a second. But so on that frame, on that reset frame, it stores where it is. And then over the next 10 frames, they're allowed to be pushed around in the sim in the way that density would be advected anyway. The reason for this is the noise, the texture noise, is going to use those positions in space to know where the texture noise should be. If the texture called for example, a hole to be created here, because the noise is going to be a black to white texture, as we're going to see in a minute. It's going to punch holes out where it's black. And that's cool. It'll make a nice little detailed, let's say, pockmarking look. Now, as the density moves around, we don't want the hole to just stay there forever as things are moving around it. We want that hole to move with our simulation. And that's what will happen. By letting these rest coordinates move, they see how it's spreading to the right, that hole will drift to the right as well, as if it was actual detail simulation in the detail. And that's what's critical to understand about this. Now, then why don't we just let it advect forever and just go around? The problem is that these coordinates will get stretched out as the simulation continues. So if we only stored the positions right here and then never updated again, all of that stuff's going to be carried and stretched out throughout the entire sim, and it's going to get very stringy, and it actually will end up looking bad for a different reason. So what we do instead is every 10 frames we start over. That way it never stretches too far before it starts over. So you're probably wondering, well, wouldn't we see the texture popping? Well, you absolutely would. And that's why we have the second group of rests. I don't have another play blast of this, but basically, if this is popping on, let's say, on the 2s, so it's 32, 42, 52, the rest 2 fields will be popping on the 7s. So there's 10 frames between these, which means 5 frames into it, from 42 to 47, we're halfway through our cycle, right? On those 7s is when the rest 2s will pop. So they're going to alternate every 5 frames. And so there's yet another value, and that's the detail ones in here, the rest 2 ratio and the rest ratio. They store in them how much to blend between the two. We can actually see the ratio of which one is which by looking in the geometry spreadsheet. And we'll see that here. It says rest 2 ratio, rest ratio. You'll see these 2 numbers are always going to add up to 1. So on the first frame, it's saying use the rest 2 representation entirely, and then it'll trade off over the 10 frames. And now it's using the rest 1 entirely. And then it will start to go back down towards the other one. And you can see now 10 frames later, it's back to using rest 2 again. And they're gonna switch off over and over and over again for the life of the simulation. It's 10 frames because I find that when it's a fast moving sim, well, it's gonna stretch out faster. So we want to get ahead of that by having a lower amount of frames as an interval. So again, 10 frames, some people do 20. If it's a slower emitting or moving smoke, you can move it to much higher numbers, 20s, 30s, 40s. In any case, we use 10 here, and just to show you this again, you can see how it keeps popping back. And again, it's just storing where the positions were, so that it can move this textured noise through the simulation. Cool. So now let's actually use that now to our advantage. So I'm going to put this back to here, so it's going to render this guy. And remember, this is what it looked like before. And so here we are. Noise enable, of course. So the noise is on. It knows to look for the rest and rest 2 fields by default, so you don't have to worry about that. Never use offset. I can't imagine why you would want to just add noise in, because it's going to add it everywhere. It's going to look terrible. So just go scale, where basically it's saying take the density and multiply it by the noise. So what we're going to try to do is get some sort of noise that represents 0 to 1, so that the 0 areas will knock pieces out and the 1s will maintain where it is. Simplex is fine. We're going to see what it looks like in a second. In fact, let's just do that now. I'm going to go into here and say, all right, let's start from a bounding box, and I'm going to make like a sliver of this simulation here, and I want to see it. We're going to use the same noise. So this is just a way for us to kind of visualize what we want to do. So here's kind of a sliver looking thing, and then I'm going to make a volume VOP. Where are you, volume VOP? There we go. And actually I didn't even make this into a volume yet. Cool. So let's give it like a whole bunch of samples. So here we have like a kind of a sliver of a volume, approximately the size of what we're working with. And I want to make a noise on here, and then I'm going to transfer those results to the shader. Now I happen to know that the shader uses this unified noise thing here. Just hook up the position to, so this is the incoming position. Remember, it's going to iterate over this for every single voxel in your sim, or in your volume in general. So the P is going to look up into the 3D noise, and he's going to output, and that's basically all you got to do. So now we can already kind of see a texture going on here at the start. I'm gonna kick this up a bunch so that we can see it better. Cool. So yeah, so it's the same interface as you can see. It's literally the same thing, 1-to-1. We want some fractally goodness here, so we're gonna get sub detail. 1-1-1. So this is x, y, the frequency in x, y, and z, and then this is time. If we animate this offset, we can actually have the texture itself be evolve on its own, even while moving through it. But I'm not actually going to do that right now. Let's kick the roughness up a lot just to get even more like